To survive and live in extreme environments, basic life support is crucial. One of the most significant natural life support systems is the oasis. Mainly found in the desert, the oasis provides water, food, shade, and more needs to travelers in extreme environments. Thus, the oasis is the main inspiration of the lunar base. We all have agreed that gardens and oases are not only a source of inspiration for architecture designs, but also a source of great spiritual and emotional comfort. Therefore, architecture shall bring life and comfort to the habitat it's built in, and offer the users a space to breathe and find the strength to continue their journey. As humanity plans to go back to the moon, private and public space agencies from all over the world are paying more attention to the moon. There are many environmental conditions to consider when building a lunar base on the moon. Our planet Earth is naturally protected against solar radiation and micrometeoroids thanks to the atmosphere, which also balances the temperatures. In contrast, as the moon is missing an atmosphere, it is bombarded with solar radiation, micrometeoroids, and extreme temperatures fluctuation. Among the different regions on the moon, the South Pole has been chosen as the location of our lunar base, because of advantages like the near continuous sunlight, more balanced temperatures, various science and exploration opportunities, and possible water resource. Let us introduce the Moon Loop lunar base. The Moon Loop will focus on two main targets. First is sustainability and self-sufficiency, and second is fungi use on the moon. The journey to the moon will start with an uncrewed mission to prepare the site prior to the arrival of the crew members. Once the base is set, exploration activities will start, including the greenhouse and ice mining. The mission would last 12 months. The Moon Loop would host 6 crew members consisting of a botanist, an engineer, a doctor, a chemist, an astrophysicist, and a geologist. Because of the pressure levels, curved structures are preferred on the moon. The cylindrical greenhouse module will extend horizontally to its full size, and it will host areas for plant cultivation, gardens, and growing fungi. The habitat module's twisting structure unfolds from a cylinder to a sphere, which allows the structure to fit in the launcher when folded, and then unfolds to host the different functions. The greenhouse modules will connect the habitat modules together, allowing the crew members to connect with plants and feel at home. The settlement starts with sending rovers to the moon to explore and assemble the site. After the launcher lands, the habitat and greenhouse modules would be transferred to the site and placed in the excavated area. The base will then expand and add other modules. The base will host several functions to support living on the moon. The Moon Loop consists of 5 habitat modules. The lower level will include storage spaces and life support systems. The ground floor will host equipment and life support area, research labs, a common area, medical room, kitchen and dining area, WC and showers, and greenhouse and gardens with activity area distributed through them. The upper level would include crew quarters, a lounge area, a communication and observation area, and a technical room. The base construction consists of composite floor panels, structural core, staircase, partition walls, polyethylene structure, inner transparent membrane, fungal bioreactor, outer membrane, ripple shield, structural openings, doors, greenhouse modules, and airlocks. The Moon Loop base aims to reuse all the resources in a closed-loop system, where little to no waste will be produced. Some of the strategies used include maximizing energy production through the use of solar light and exercise machines, water recycling, and utilizing greenhouses to produce sufficient food and circulate air. The Moon Loop base will use a fungal bioreactor shield that can protect against radiation and self-repair when needed. The shield utilizes a multi-layer membrane system, preceded with fungal biocomposites that inflate once nurtured through the structure's circulatory system upon arrival. Covering that is the Whipple shield, which would protect the modules against micrometeoroids. The Moon Loop concept aims to provide a sustainable self-sufficient lunar base to support long-term exploration missions on the Moon.